If you're running a CAN network, you've probably already run into the same handful of limitations that come baked into the protocol. Extending your network further away usually means dropping your baud rate for the entire bus, and if you've got one section that needs to run faster than another, CAN doesn't really give you a way to do that since everything shares one common rate. Now on top of that, if something goes wrong on one section of the network, it can end up taking down communication for every device on the line, not just the one section that's actually having the problem. And most engineers just treat this as the cost of doing business with CAN. But the one thing that most engineers don't realize is that a CAN bridge solves all three of these problems at once. And ICP DAS USA has a full lineup of bridge modules that go way beyond standard copper wiring, including fiber optic bridges that can carry a CAN network up to 30 kilometers. So in this video, we're going to be walking through 4 CAN bridge modules from ICP DAS USA, what each one is actually built for, and by the end, you'll know exactly which one fits your application. So let's start with the foundation of the lineup, the I-2532MFD. This is a 2-channel CAN bridge, and what it does is sit between 2 CAN networks and connect them together while keeping each side fully independent. And that independence ends up solving all 3 of the problems that we just talked about. For one, the transmission distance on each side gets calculated separately, so your total network distance basically doubles without you having to touch your baud rate. Each channel can also run at its own speed, so that faster section and that slower section that could never coexist before, now they actually can on the same overall system. And because the 2 sides are isolated from each other, if a bit fault shows up on one side, the other side just keeps running like nothing happened. If you've ever watched one noisy device take down an entire CAN bus, you already know how valuable that last part is on its own. Now, that handles the distance, speed, and fault isolation over copper. But here's the thing most engineers don't realize. Copper isn't even close to the ceiling. The module that really changes what a CAN network is capable of is the I-2533CS. This is a CAN to single mode fiber bridge. It extends your network up to 30 kilometers over fiber. The distance limit that's normally tied to your baud rate just doesn't apply once you're running over fiber, so you keep your speed while covering distances copper could never touch. It still carries the same core bridge features too, so bus errors stay isolated to one side, and both networks can run their own baud rates. So if you've got buildings, substations, or sections of a facility that are separated by serious distance, this is what ties them all together as one network. Now, single mode fiber is built for going the distance, but a lot of facilities actually have a different problem. That problem is electrical noise. That's where the I-2533 is extremely important. This is a CAN to multi-mode fiber bridge, and it's built for shorter fiber runs where the real value isn't distance, it's immunity. Since fiber doesn't carry an electrical signal at all, it's completely immune to the kind of electromagnetic interference that causes chaos on copper CAN lines running near motors, drives, welders, and other high voltage equipment. So if you've been chasing down intermittent CAN errors in an electrically noisy environment, moving that section onto fiber with the I-2533 doesn't just reduce the interference, it removes it completely. And if you're already running on fiber, just stick with me here because this last module can cut that cost down quite a bit. That's the I-2533CS-A and I-2533CS-B. These 2 work as a matched pair, and what makes them stand out is something called Wavelength Division Multiplexing. You see, normally fiber needs 2 strands, one for sending and one for receiving, but this pair sends bidirectional CAN data down a single fiber strand by using a different wavelength for each direction. So instead of pulling 2 strands on every run, not only do you only need one, but that cuts your fiber deployment costs across the entire installation. It's one of those modules that nobody thinks about until the fiber quote comes back, and then it suddenly becomes the most relevant thing in the conversation. So let's take a quick look at where we are now. You know how to solve every major limitation of a CAN network with the ICP DAS USA bridge line. copper to copper bridging with independent distance, independent baud rates, and full fault isolation with the I-7532M extreme distance up to 30 kilometers over single mode fiber with the I-2533CS, complete noise immunity for electrically harsh environments with the I-2533, and single strand fiber deployment that cuts your cabling costs in half with the I-2533CS-A and B pair. Every one of these modules is DIN rail mountable, built for industrial temperature ranges, and backed by ICP DAS USA's free technical support, which means when you call, you're talking to an actual engineer who knows the product, not a call center reading from a script. Thank you so much for taking the time to watch this video. Links to every single module that we've covered today are in the description below, and if you want to see the full CAN bridge lineup, head on over to icp-usa.com, or if you want more information from our team, you can reach out to us at sales@icp-usa.com.